Cari colleghi, Guido, Beta e tutti, sono molto contenta di essere con voi alla valutazione degli interventi a questo convegno Scienza e Beni Culturali, ancora una volta Bressanone, presenting innovative transdisciplinary smart digital methodology for quality control in the rehabilitation of emblematic monuments within the aspects of Evlogon project. I have to start with the question, how can we ensure that rehabilitation interventions preserve authenticity, improve performance, and guarantee sustainability with respect to the values and history of the monument? In this direction, quality control objectives concern structural integrity, compatibility of materials and rehabilitation interventions, and long-term sustainability. Of course, we are speaking of an interdisciplinary quality control throughout the rehabilitation and the life cycle of the monument. That means before rehabilitation, we are dealing with diagnosis and documentation from architecture, structural integrity, geometry, the 3D photogrammetric documentation, materials characterization, decay assessment, pathology and risk assessment, going to the strategical plan and proposal for rehabilitation. During the interventions, quality control concerns compatibility, performance, validation of projects' achievements concerning rehabilitation of structural integrity, sustainability of interventions, preservation and reveal of values. And after rehabilitation, the monitoring concerns the ongoing sustainability, the preservation state, the multimodal performance and health monitoring concerning hydrothermal stresses, earthquake stresses, and assessment of vertical deviations. Smart digital and technological tools enabling quality control concern multispectral data acquisition, for instance, for the 3D documentation, LiDAR and total station, non-destructive techniques, material characterization, structural modeling, smart technology, sensors. And from measurements to knowledge, that means from raw data, we are dealing with elaborations like 3D model digital platform, fusing and merging all disciplines data for decision support, multi-layer information model, assessment, quality control decision, and a digital repository. Within Evlogon, where a consortium is participating with National Technical University of Athens and me as coordinators and scientific responsible, we are dealing with the model interdisciplinary development and transfer of know-how and cooperation in the restoration of emblematic monuments, highlighting the values of Christianity in dialogue with society. The Evlogon concerns emblematic monuments like the Holy Edicle of the Tomb of Christ in Jerusalem, Hagia Sophia in Istanbul, and one of the most important post-Byzantine monuments in Greece, Virgin Mary Varnakova. Of course, our work concerns as well a cycle of works, as you might see here, and it is enriched with model implementation of new projects in a hyperdisciplinary dialogue between engineering, archaeology, history, theology, even sociology. It started with the Ecumenic Patriarch in Istanbul, and it is promoted through the Technical Chamber of Greece and the national network which is now dealing with standardization. The Evlogon data repository permits the presentation of quality control in the project's case studies. We might start with the emblematic Holy Edicule of the Holy Sepulchre, which was an initiative of the Greek Orthodox Patriarch of Jerusalem, Theophilos III, who invited me and the interdisciplinary NTUA team that I comprised in order to respond. Within the diagnosis, we performed documentation, diagnosis, and proposal on an interdisciplinary basis to address the challenges of the deformation of the Holy Edicule. And we started with the innovative prospection of the non-visible layers of the edicule as a major tool for its rehabilitation. Here you might see the ground-penetrating radar results on a 3D representation. And all the data of materials, structures, geometric representation were composed at the finite element model for structural documentation, and they were an input to the proposal for rehabilitation, which became feasible after the common agreement of the status quo after 2 centuries to go on with the project. Within the project, the main issue, always with respect to a decision-making by the Christian communities in a very challenging environment, scientific support was the major task to decision-making, and that's why quality control in the implementation methodology with an integrated governance of the project became the utmost tool for assuring that compatible and performing materials were used, and that through the iterative process of the main stages of the rehabilitation, all the interventions were serving the goals of the project. Upon the completion, we can ask, were these aims achieved? Actually, assuring structural integrity, we had to register time evolution of the column's deviation from verticality by a general geodetic station, and at the same time we had to record a multi-layered finite element model which would assure that the response of the retrofitted structure was validated and was capable to address the earthquake history of the area. Revealing and preservation of values from the archetype material of the burial monument to the mere bearers and to the tomb of Christ were the major tasks for us. And when we opened the tomb of Christ after many centuries, it was a very specific experience of quality control to reveal its values by archaeometric luminescence dating methodologies, which investigated various historic periods on the tomb, and by metagenomics and bioinformatics concerning the microbiota characterization of building materials of high historical and archaeological significance, which were cross-linked with the archaeometric results. In this end, the non-destructive techniques prospection of the tomb of Christ revealed many issues of its morphology. Of course, the overall sustainability of the rehabilitated Holy Edicule in the environment of the Church of Holy Sepulchre was a major issue, and infrared thermography testified intense rising damp phenomena. Hence, we had to document by 3D digital non-destructive prospection the underground tunnels representing all the risks of underground water, and at the same time the geometric documentation was the common background to manage all this data, which permitted us to present the study for a peripheral drainage and ventilation gallery to support the rotunda and to facilitate drainage and ventilation systems of underground perimeter corridor and installation of new sewage and rainwater networks. This was a pre-requirement for the future work, which is now undergoing in progress. Remote data acquisition for a multimodal performance health monitoring was the third stage, the after rehabilitation, which, however, did not have a duration for more than 6 months. In a few words, quality control implementation at the Holy Edicule in all the phases before, during, and after was considering the certain processes of quality control that I presented, and has proved actually that quality control is feasible and gives valuable results. In the case of preservation and revealing of the Hagia Sophia Byzantine structure of Justinian within the protocol agreement of '94 between Princeton, NTUA, Bogazici, and Kandili Observatory, we had the experience of working through the characterization of historic materials and their plasticity to earthquake risks, and the response recording of Hagia Sophia in certain earthquake risks to actually organize by a finite element model the future intervention with compatible and performing materials, which was accomplished by June '99 in concerning compatible restoration mortars. A lot of work was done, and the criteria to the quality control of these mortars in order to achieve the minimum possibility of failure in the expected earthquake frequencies in relation to the modulus of elasticity of the mortars was a major issue of quality control, and of course for validation at the level of the seismic test bench at the NTUA. The Hagia Sophia finite element model, a dynamic analysis of this data validated even in the lab, and the static analysis, the non-linear after application of simulated earthquakes, and the pilot application of the restoration mortars permitted after the big earthquake of 7.4 Richter of Istanbul that nature has presented Hagia Sophia shaken but not stirred. And the achievements of the project are important for a valuable quality control concerning earthquake protection of emblematic monuments. In the case of the Holy Monastery of Varnakova, which is a major post-Byzantine monument in central Greece, which was actually a focal point for the national liberation struggles of 1821, it was an effort by the same team of NTUA to apply the interdisciplinary methodology that we used at the Holy Sepulchre. And from that point of view, the 3D scanning and the stages of interventions with compatible materials and rehabilitation interventions were monitored continuously for the quality control of the interventions with the same methodology before, during, and after the performance of the work. Through the quality control methodological framework applied in Evlogon in these different case studies, we might discern the quality control objectives, methodology, tools, and control parameters, let's say, for structural integrity, for materials compatibility, for interventions performance, for decay and risk diagnosis, and for long-term sustainability. Although each monument presented different challenges, the same quality control workflow was applied: documentation, diagnosis, intervention, validation, and long-term performance assessment. From Evlogon methodology to quality control standardization, we are working now at the Technical Chamber of Greek engineers, all Greek engineers and architects, and within the national network, we are going from methodology to standardization. As we say, through guidelines and technical instructions that permit all these procedures of diagnosis, quality control during the works, and for a continuous monitoring afterwards, that we will be describing through these guidelines all the required documentations, interventions, assessments, and sustainability criteria. All the standardized requirements are within this procedure, and we are, through Evlogon, transforming scientific methodology into applicable standards, supporting quality assurance throughout the entire life cycle of monuments rehabilitation. The question for the future is, are we going to promote international standards for quality control, discussing our experiences in conference networks like TMMCH, Scienze e Beni Culturali, of course the national network of Evlogon, integrating them on common proposals on the level of EU, on international regulations and standards. This is an issue that I am very happy we are discussing it here now in Bressanone, and I am inviting you to come and continue this discussion at the proper panel at the 5th International Conference Transdisciplinary Multispectral Modeling for Cultural Heritage in Athens from 14 to 16th December 2026. I'm glad that I'm here in Bressanone, and I will be happy if you come to Athens.